right, so here we have our anterior view. Here we can see kind of the base of the heart. Here we have our interventricular blood vessels here. Because we know this is the right side here, so that means this is our right auricle. This would be our left auricle. So let's check. Well, there's the left. That makes sense. So that means this is going to be our left ventricle. Once again, just like we thought. Hey, stop doing that. All right, here we have our right atrium covered by the right auricle, which is going to be this little ear-like flap of tissue. And then finally, we have our right ventricle. So all that should be fairly straightforward there. Now, importantly here, we have the division between our right and left ventricle. So that means it's going to be our interventricular septum. So we can see that here. Then we have our left atrium, our left ventricle, our right atrium, and our right ventricle, both on the real heart and on the model there. And that's one of the reasons I really like these APR assignments. We can also see kind of where the heart is in space. I guess we'll just go and click through there. So big arching vessel is our aorta. The things that hold it in place, we're going to call the ligamentum arteriosum. This is basically the connection between the pulmonary trunk and the aorta. So there's our pulmonary trunk, and then there's our superior vena cava. Now here we can highlight some of the blood vessels. All right. So now here we have the heart. So one of the first things that we want to look for is going to just be kind of our, say, our chambers. So that means we have to slice through kind of this way. So let me go grab some gloves and we'll do that with the heart part. Stop sharing. All right, so can you all see this relatively well? Like, can you all see pretty well? Just out of curiosity. Okay. All right. So here we have a pig heart. Okay, so this is a heart from a pig. Now, if you're wondering if this is actually like a good facsimile for a human heart, it's a good question. However, it absolutely is. If you want to know how good of a facsimile it is for a human heart, they've actually installed now 2 of these into human beings as transplants. The first person did pass away after a couple of months due to an infection, but also they had a bunch of other underlying issues which necessitated them to need a heart in the first place. So that one they passed. However, there was another successful transplant a month or so ago, and that person is still going strong. And they're doing all of the cardiac rehab stuff to try and like get the body back functioning, but the heart is actually doing what it's supposed to be doing, which is great. So this is actually a pretty good facsimile for what we need, for what we are looking for from the heart. Okay, now first off, we can notice that it is covered in a whole bunch of fat. Okay, this fat is important as kind of cushioning while also kind of being a little bit of a nutrient reserve for the heart itself. Now we do have some kind of empty spaces here in between the fat. These are basically going to be places that are subject to friction, whether it between the sternum or the diaphragm or something like that. Now, because this has been in a bag and it was compressed with a bunch of other hearts, its shape isn't quite perfect. Here we actually have our left auricle. Here we have our right one over here, but it's just kind of been twisted and torqued as things were moving around. So the shape is a little wonky, but we can see our apex of the heart here. We can also see our interventricular artery right here. So we can see some of these vessels. Just understand that it's kind of been torqued and twisted a little bit, where it's not quite looking as perfect as it should. Now we can actually kind of squeeze it and press and try and get it to kind of reorient a little bit, which is what I'm trying to do here. We can also see at the top of the heart some of the great vessels, whether it is our aorta or our superior vena cava. So we can see some of these. So now let's go ahead and, or sorry, there's our superior vena cava. This is our pulmonary trunk. So here's our aorta, here's our pulmonary trunk. So let's go ahead and see if we can't get this bad boy open. Now, one great tool when kind of looking through these is actually going to be kind of our probes so that we can kind of see exactly where these vessels are going. Also, y'all don't need to worry too much. Like, this is not something that we're going to be asking questions from. This is just more of a kind of personal edification sort of thing. Like, if you are curious about it, that's why we're doing this. Like I said, we're not going to ask questions based off of this particular heart. I'll use the models, or I'll use those figures I was just showing you in the anatomy and physiology revealed. Can be tough to get through, especially this left side because of all of that muscle. So y'all can kind of see what I'm looking at here, where you can see all of this connective tissue. So we have all of these muscle fibers. You can also see that I'm cutting right now through one of the valves. And I'm trying to do so as cleanly as I can. Now, whenever you're doing a dissection, you want to use like single long strokes. You'll notice that I'm not stopping to really cut anything. Like, I'm not stopping to saw. I'm trying to let the blade do all of the work. And my hand's just kind of here to help pry it apart so that I can get access to more tissue to cut. And no, that is not heart juice. That is some preservative. So don't worry too much about that. Okay, that was reasonably successful. About as good as I could have hoped for, to be honest. So what we've done is we basically have separated our left side of the heart pretty well. We can tell it's the left side of the heart because we have a ton of mass here. Okay, wait, hold on. Where do I need to be? Okay, there we go. So we can see all of this muscle down here. So this tells us that we are in the wall of the left side of the heart. So here we can see the wall of the right. Notice how much thinner that muscular wall is. Okay. Now, on this side here in particular, we can get a really good interior view of some of those papillary muscles. So we can see the papillary muscles connected to these structures here. Anyone, what were these cords called? Anyone remember what these were called? That connect it to the valve. So here we have the valve, and here we have these little cords connecting to the papillary muscles. What were these called? These were the chordae tendineae. So here we have our left atrioventricular valve. We can also see our aortic semilunar valve right here. Notice that its structure is quite a bit different here. That's because this vessel is going to be subject to ridiculous amounts of force coming through it. So we're going to have really, really high blood pressures here, but these blood pressures are actually so high that it's actually going to be really unlikely for blood to try and kind of fall backwards this way. But this way, we just need these kind of, we just need it to open or just hold itself closed a little bit with these semilunar valves down here. Let me see if I can get one of the atria. So up here, this is going to be our left atrium, so kind of where my fingertip is here. Here, you see it a little better on this side. So this is our left atrium. Now remember that the atria are basically going to be like little primer pumps. These are going to kind of have blood drain straight through them in some cases. So blood will just basically flow directly out of the superior and inferior vena cavas and fall straight into and start filling the ventricles, or in this case, because it's the left side, where they'd be coming out of the pulmonary veins and just kind of falling straight down into the ventricle. But instead, we have a little layer of muscle. So you can see that the muscle layer here is quite thin. So, I mean, in this case, it's genuinely like 3 or 4 millimeters thick, if that. Okay. Why? Well, we have that little bit of muscle so that as we are getting ready to contract the ventricles, we can actually squeeze the atria just a little bit to make sure they are completely drained and pushing some of that blood or the last of that blood down here to the ventricles. So the ventricles are completely filled and completely stretched before the ventricles contract, at which point they will send the blood out into, so the atria contract, send blood into the ventricles, and the ventricles contract, sending blood either to the body, which is the case for this side, or the lungs, which is going to be the case for the other side, the side which is kind of thinner here. So yeah, here you have this nice view of our atria. You can also get a nice view right here of our coronary artery, or one of our coronary arteries. So you can see a little divot kind of right here. It's not wanting to focus for some reason, but there's another one right here. So if this is our aorta, we can see this little branch. There's one on the right, one on the left, at which point this is basically where blood is going to leave the ascending aorta and immediately get routed down to the blood vessels of the heart so that we can actually get all of these heart muscle cells, all of the nutrients and stuff that they need. Trying to think. That's probably about as good of a cut as we're going to have of that. Trying to think. Are there any structures that you all want me to try and find in this pig heart before we just kind of call this dissection a day? So is there anything else y'all wanted me to see if I could find? I make no promises because sometimes, like I said, these preservatives can make things where they're not quite as easy to see as on the real models or on the heart dissection, which is not necessarily a super well preserved tissue. Well, I guess I will take your silence as golden. If y'all do have any questions, I really recommend, especially for this class or this section, look at your anatomy and physiology revealed assignments. So connect to your McGraw-Hill account directly. So go to connect.mheducation.com, log into that directly so that you can access the anatomy and physiology revealed here, and this will do a great job of showing you a bunch of this anatomy. And then next time when we come in, or on Wednesday, I will go over kind of the signal conduction pathways, and we'll talk about how each of these things contracts in order, how that contraction works, and then also how we can see all of that stuff on something like an ECG. If either one of you have Apple Watches or something like that, you can actually measure your own ECG at home, and we'll actually go over kind of what to look for in those, or at the very least, kind of what normal physiology looks like on that front. And then we will talk about some little experiments we can do to kind of change that. So we'll do like a little bit of a breathing exercise and show you how that is actually going to decrease cardiac output. And then we're going to do some exercise, and we'll show you how that increases cardiac output. And we'll show you kind of some of the mechanics of how that stuff's going to work in the heart itself. So any questions? All right, well, if that's the case, I hope y'all have a wonderful day, and I will turn this thing off. Y'all can still hear me, right? Okay, I see my little thing moving, so I guess you can. All right, y'all have a great day.